then everybody will get it.
Okay, so today, kind of funny, the plan for today is to do some essay 7, okay? And then to do some planning. It's like when you realize there's no plan for today, then you need to do some planning. Um, okay, so essay 7, I was about to do, um, yeah, like I've drafted my email for A level, which I'm gonna send out after daylight savings, and no one asked me about daylight savings. And in it, I was describing essay 7, like, could be one of the hardest problems ever encountered, telling you how hard it could be and trying to scare beginners into not trying it, right? And then I look at last year's essay 7, where it literally gives away the answer to the first part in the second part.
It's a bit of a bro.
So I don't know if I could actually continue that line of intimidation anymore. So where is the problem? It is in session planning. See, is it necessarily true that at least one of its 4 cells is fully covered by one of the triangles? Okay. Is it necessarily true that some square of size 1 by 1 can be placed into one of these triangles? So yeah, like B implies A, right? And so seems like you can get all 12 points by doing one of the parts in one of the directions. Yeah. Okay, so the example for part A that we got is in the see this spoiler.
Ooh, spoilers.
It's here.
Spoil the problem.
So it looks exactly like your example, right?
Yeah, it's the swastika.
I don't quite see a swastika.
Yes. Imagination.
But also, if it's like the other way, it looks like it's like the Buddhist symbol for something.
Yeah.
So that's probably the more PC version of
PC. 1, 2, 3, 4. Are these 4 different spoilers?
I guess so.
Whoa.
So the order in which I did things. So here I was kind of imagining stuff, cutting stuff, and I was using the grid line, so I didn't have to draw a 2 by 2. And then eventually we came to the conclusion that it can be done. Okay? So you just gotta pick sort of 2 pairs of non-parallel lines that kind of leave. So it has to kind of go through certain. It's like the red line has to go somewhere between, probably somewhere between here and here, right?
Yes.
And then on this side, it has to cut somewhere between, well, here and here, or it becomes like the blue line. Well, yeah. So this was more just like kind of fiddling with diagrams and stuff. Yeah. Is that how you did it as well?
Yeah. Well, Alex was doing some systematic stuff. I was just drawing random triangles. I was like just trying to prove. I don't know. Trying to prove it wasn't like that the proposition was correct, and then I stumbled upon this because it was like one case out of like 50 cases.
Yep. Okay, and then so then there was also like kind of the the question. It kind of lingered in the back of my mind if the triangles, like obviously I never considered if it had to be inside the square or not, and just thinking like what happens if the triangle has to be inside the square, or what constraints there are on the triangles. Yeah. And so this is one of the key lemmas I think I stumbled across. So I guess all these things actually have the lemma in the mind.
Lemmas.
So this is the lemma, I guess. Maybe I'll make some notation. How do I make the notation? Alright, let me just state it and then let me write it. So the lemma is basically like if you have 3 points inside one of your covering triangles, then the triangle that those 3 points make up is also inside the covering triangle.
Wait,
It's like the most obvious convexity lemma you can think of.
oh yeah.
How would you say that?
Bro,
Triangles
that's
are
just
convex.
convexity.
Yeah. So if you have like,
Oh, this is
so you think of the triangle as like, it's like triangle 1 and triangle 2 covers like this like square. Yeah.
wow, this notation. Yes.
And so if you have like, so like if you have A, B, C is in triangle 1, right? Maybe you could have like some notation that the triangle defined by ABC is also in triangle 1. So notation helps with writing. It saves time writing.
Yeah.
So maybe that's the lemma. You know? If A, B, C are in the triangle 1, then yeah, and you might want to define the triangle 1 as the solid, like every point inside as well. How would we prove it?
Triangles are convex.
Triangles
Yeah.
are convex.
I guess the informal proof would be triangles are convex. Maybe
Top 10 proofs of all time.
I don't know, maybe like a definition of convex might be like
Connecting any 2 points.
like C is convex if anytime you have like A and B is in C, right? Then like maybe you can define something like the interval AB is in C. Yeah, or you could come up with some other notation for interval. Yeah. But you have to define this, yeah? Yeah, it's funny because a lot of people they set it up so much and then they just get like the nice statement. Like if A is in S, then B is in S. And then take like an hour to define S.
That is quite amazing.
Yeah, so obviously the outside of the triangle is just IAB union IBC union I AC. But then if you have anything inside anything inside the triangle, then so is IAX, I guess. No? Yeah, and it's also inside triangle 1, yeah? So that means X is inside triangle 1.
Wow.
Okay, so that could have been written a little bit better. But yeah. Okay, so maybe something like this is kind of like trying to prove. So what happens if? So this actually is the argument kind of applies to even when the triangles don't cover. Like they don't have to be inside the square. So this is the case where sort of you have 4 corners, right? And if you're covering by 2 triangles, 2 of the corners have to go inside one of the triangles. And then you have cases where it's like 3 and 1 or 2 and 2, right?
Yeah.
I think 3 and 1 is obvious, right? If you have 3 corner points, yeah, then by the lemma you get this triangle, yeah? So you get this square, yeah? So this number 3 is the case when there's 2 and 2 and that it's the sideways 2. It's the left 2 and the right 2.
left.
Can anyone see how to prove it? So you have these two. So if you call it A, B, C, D, it's basically A and D belong to triangle 1, right? And B and C belong to triangle 2.
Oh, if, like whichever triangle has the middle one,
Hmm.
then like if it has one of the like, up or down ones, put it above and below,
Yeah.
then you fail. If it has neither, then the other one has to have like those 4 points.
Yeah.
Ah,
and you fail.
Makes sense, right?
yeah.
So it's kind of like, well, log, this point is
people.
hello.
Yes.
Yeah. We try to
Oh, actually,
shrink the triangle as small as possible.
What?
Oh, please.
Let me make him co-host.
Wait.
Wait, what do you say?
You can try to belong that the triangle is as shrunk as possible.
Yes, you can.
You can shrink it in some
Oh.
dimensions,
Yeah.
and yeah,
Hmm.
so you can make it. So if you're doing so the opposite corners are in a single triangle, which means
Oh, that's number 4, yeah.
you can make the base of the triangle. You can move it towards the. You can make it hit the corner.
Yes.
Yeah.
And then yeah, what else? To move the opposite vertex closer until it only exactly just covers it.
Yeah. You're talking about part B, aren't you?
This could be for, but yeah, could be wider of them, I guess. So
I think we lost a bit of sound here.
wait, hello, anyone, someone, hello.
Hello.
So part A is talking about the specific cell. So the weird, so they said they gave it away by saying A has to, if A is
Yeah.
A is true, then B is A is true, then B is
Yeah.
If these
Then-
So B implies A. So like, wait, no, A implies, well, one direction of one of them implies the other one.
depending on which way. Yeah.
So like, you're basically getting 12 points for doing part A in one direction, or 12 points for doing part B in the other direction.
wait. So this is saying no matter how you do the triangles,
Yeah.
no matter how you do the triangles, you can always have that square. Yeah.
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 Yeah. So for example, here, see, like, the great thing about the lemma is it removes the 2 triangles. You don't actually need the 2 triangles anymore. Unless you're
Points.
constructing the example. Well, like, yeah, so for example, here you see like the middle of the square, you can log to be purple, right?
Yeah.
And so by the lemma, you get the whole, this is all part of the purple, yeah?
Mm.
I mean, it can overlap, right?
Yes.
And then you can log stuff like, this is part of the black, right? Because if it was part of the purple, you get a purple square, right?
Oh,
One's also
that's not.
Yeah.
Yeah, so that's what this
Same
kind of
with the-
diagram means.
Mm.
And so you get this black triangle here.
Trying to extend the triangle by adding more and more points.
Yeah.
Okay, what about the opposite? We have opposite corners. Then
Oh, you already moved on to the opposite corners.
Wait, top,
Alright, let me just
wait,
quickly
top
write
corner,
this.
So the top
Uh,
corner purple. No, wait.
So the
top
top-
corner can't be anything. Wait.
Yeah, the top purple, the
Can't
top
be-
one's a contradiction now, right?
Contradiction.
Contradict.
Yeah. So what did we prove actually? Can anyone say what we actually proved?
Prove that.
So the most general statement possible. Well, so it doesn't necessarily have to be like
Do that. If the
One
black
of the
triangle has
best.
AD and the purple has ABC,
yeah,
then guaranteed to have a square.
yeah. So you can't find an example where they're
This-
covering the
Also, this can be applied for part B. This could be used as part of the part B proof if it's true. Right?
yeah,
You could.
But if part A is false, then that it only helps for part B.
yeah. And also, if you're looking for an example for part A, you can't look for where they're covering the two sides like that.
Yeah.
Okay. So maybe then instead of so then 4, right? As an exercise, maybe you can say so. So I guess the point is it's impossible to prove that you can't prove the same thing with 4 as you could with 3, right? Because we've already found an example.
Yeah.
But maybe you can prove like it can't be done if the triangle is confined to the square or something like that. Maybe you can do that right now as an exercise.
Wait, 4 of what?
Triangle is confined to
Wait, 4 of what?
So basically, if you're forced to have like triangle 1 is inside of square
Yeah.
and triangle 2. Can you prove that this case is also impossible, where you have basically instead of having AD, you have BD is in triangle 1, and CA is in triangle 2.
Is this the opposite case? Wait.
Yeah, this is the diagonal points case. Now you have 2 points and 2 points, but they're diagonal to each other.
I see. So that you have to have for the edge, the midpoints of the edges. You have to have this setup because if you had any adjacent ones that were the same color, then you would have a square.
What?
Yeah, it has to be that setup.
Well, that doesn't even matter.
Yeah.
Did he even say like, you know that those 2 points have to be 2 of the vertices?
So like this point here
Yeah,
has to be one of the vertices.
because if it like extends past, it's like outside the square, right?
Yeah,
In like any direction.
but what if like it was the sides like this? Wait, actually, that's still a vertex.
How do you even
I'll
get
read
this?
this.
You can't get this set up. I'm pretty sure. Pretty sure you can't get it.
It is not a vertex, it must like on either on the side or inside. So we know it can't be inside, so it has to be on like the side.
Mm-hmm.
Yeah, and like the side could be anywhere, but like where the side extends past the square, like can't be part of the side. So that point itself has to be the end of the side.
Yeah.
So yeah, but after you assume that like that you can log a third vertice somewhere like in like
Yeah, okay, let me just
on
draw
one
it.
side of the line.
So if you have like this and this, right? Then you have that.
Mm.
And if you have this and this, you also have that, right?
Yeah, those are both like sides, and then
And
you
then
can pick like a pink third vertice.
yeah, you can log this as blue, right?
Yeah.
Because it's symmetrical.
Oh, I was gonna do like a different color argument.
Oh, okay, yep, keep going.
Like if the third vertex is like above the blue line, then
Oh, the third vertex of what?
of the blue triangle.
Oh,
Because you know it's inside the square, so you can like it could be anywhere really.
Oh, so you're saying those two are
the
definitely
right-
vertices of the triangle?
Yeah. So after you say that, like
Oh,
picking the third vertex is like very strong, you know.
yeah.
Because like you pick it above, everything below cannot be blue, and it like the pink vertex is either above or below.
Oh, yeah. It can't cover the. It can't even cover the square.
Yeah.
Okay.
Wait.
Yes.
Actually, wait. I'll go on the whiteboard.
Oh, that's where it is. Thought I lost my part B.
Wait. Wait. Did we finish anything, or was that we still doing? Continuing. Part A.
Oh, I think we finished with part A.
So
So
what
part A,
was
we
the-
ended up. So basically, the idea was we definitely need something that cuts the diagonal corners,
yeah.
and this was the example that we came up with.
Yeah. Okay, yes, that's not. Wait, hang on. So it's meant to just miss the midpoint. Oh. So it,
Yeah, you actually have quite a lot of room to work with.
Yeah, you can slide the points like a lot.
So as long as you're kind of
Hmm.
so the blue line just makes sure it has to it has to be. So
you make the things past the midpoint.
like the blue line should cut between these 2 points, and probably also between these 2 points. Yeah.
Yeah.
And then over here, yeah, like the idea is it leaves basically just the 2 corners for the other triangle.
Yeah. Oh, yeah, and you have to look at the 4 points. You have to look at the 4 midpoints of the square. Wait. Yeah, we need the 4 midpoints of the square.
Like, it just has to be between the midpoint and the point.
Yeah. Yeah, so it's funny, like we have all the lemmas, right? But the write-up for part A is literally just like,
Draw diagram.
yeah. I mean, obviously, it's gonna be like people are gonna be like, oh, he gets the so it's 6, right? But like a rigorous proof might be like you need to prove that the red lines are not parallel
Yeah.
and the blue lines are not parallel.
And you just like state some coordinates or something.
Yeah. Yeah, so it's kind of weird because like you're obviously wasting time in the exam if you're writing those things, but
Yeah.
it is good to know what a complete proof looks like.
Why does the schedule say team meeting at 3 p.m.? Is the future next year IMO team meeting?
Yeah. Yeah. Yep.
Meeting for the next year IMO team.
Yeah. Yeah.
That is clearly going to be within us.
Yeah. They'll have to create a new state just for us. There's too many people in this particular location. All right, so maybe as an exercise, you can prove part B now.
As an exercise. I mean, what? I don't.
Kind of using dilemmas and these
I
ideas.
have absolutely no idea.
How to fit squares in part.
Okay, well, how would you start the proof of part B? I think you guys, even though you didn't fully get part B, you actually got a conjecture, right? Like it was a yes or no.
Yes.
You thought you can always fit a square in, right?
Mm.
Okay.
That was our conjecture.
Okay, I was expecting a better conjecture, but
Like
Well,
something.
that's an asshole. What if this is just another construction and then we
Okay,
just
so
forget-
their idea was basically like this example is pretty much the only kind of example that was part of your.
Oh yeah, that was part of it.
And if you look at the parameters of this example, no matter how you shift the blue lines and red lines, there'll always be a 1 by 1 that's in the middle, you know? And I do believe if you can actually prove that these are the only examples, you can certainly chord bash the
One by one.
yeah, you basically just need the distance between the lines to be more than 1, right?
And then
So the distance between the line, you just take it's one of the endpoints, right? Like it's one of the endpoints. Do you know how to do the distance between a line and a point?
well, which one?
Oh, like the blue lines, for example.
Oh,
Like the distance between the blue lines is really just this point here to that line, right?
We learned that in school math.
Do you have a point distance to a line formula?
Yeah.
but what are we trying to prove? Like, you can draw
You prove that like this distance is always bigger than 1, right?
always.
Oh, wait.
Well, it's not always.
Oh, isn't it?
Oh, you mean within the quadrilateral?
Yeah.
Distance between parallel lines.
I'm not sure this. I think you sometimes you do have to pick between
Yeah.
like pink and blue. Like one of them, I think you can fail.
Yeah.
Wait, when they say 1 by 1, is it like it doesn't have to be horizontal 1 by 1, right? It could be like
Yeah, it
diagonal.
can be rotated. But I think if you just do distances, like sometimes the distance is like what was the example?
You pick the points
Oh,
to be
yeah.
as close as possible to a parallelogram.
You
Okay, so the distance of the line. So where's the distance being measured?
Well, move this point there and move this point like close to here. The distance from here to like a line going like that, this is less than 1.
Oh.
But that's like a weird
Mhm.
kind of.
Okay, so that simple argument won't work, I guess.
Yeah.
Okay, but what about using the lemma over and over again?
Oh, the lemma.
Yeah, I don't know.
So if this was your grid, right? Okay, how would you start like a proof of that see like the thing is, even if you didn't know if it worked or didn't work, the proof would start the same way, right? Because like the proof also helps you find the counterexample.
Yeah.
Yeah.
Wait. So you have opposite points.
Okay, good.
Oh.
Alex says
I think that's I think somebody in maths at one said. Even if you
Also
try to
think
prove it,
that the middle point is
Huh?
belonging to both.
what'd you say, Yasser?
I said you can do work. You can make progress that either proves it true or false at the same time. Such as,
Yeah.
when you attempt to prove it is true, it helps you find a potential counterexample that makes it false. So
Yeah, like where your proof kind of gets stuck.
yeah,
Okay, so Alex has suggested good. We have to have diagonally opposite corners, right? Because we know it doesn't work in the other case.
Yes. The middle point belongs to both of them.
Well, I mean the whole diagonal you can color.
Okay, good. So
You can
that's
just color
you know.
Okay, as for the edge points, if
So this should be a team solve without my
for
spoiler.
the edge points, wait, let me think. Which points of this? Okay, for the edge points, we have like two cases, which is either they're like two of them adjacent or they're opposite.
So Leo said midpoint of the
I
sides.
think that's what he meant.
Yeah.
He
Yeah,
just said
just more specific. Said sides.
So if there's adjacent ones, then it's gonna form at least a square. Because
it can't be like I have two blues.
So what am I coloring in? So color this one red.
Yeah, if that's pink, then the one below that is, or like the one
This one.
on the right.
so if you
This
color-
one's blue. Yeah.
Yeah.
Oh, that's epic.
Oh yeah.
Wait.
So if they're adjacent, then
Okay. I'll do the. So everything that needs to be done needs to be said. I'm not completing any sentences.
okay. So
Oh wait, this is
if adjacent ones are the same color,
Oh, okay, good.
okay, yeah, the bottom one has to be, and then the remaining one obviously has to be blue because otherwise the square will be formed. So now we have a pro gaming setup.
oh, it's very symmetrical.
How to
That's a
make this
great
program
piece.
gaming setup into a thing.
Oh wait, actually you can do even. So that means you just make this entire line.
Spoiler.
Spoiler incoming.
Spoiler incoming.
Yes, you gotta do it. So Yasser is like the time limit. Okay.
If you can't do it for Yasu,
Somehow, which is kind of a very hard benchmark to make.
Yeah. Yes, sir. Speed.
Okay,
It's just
It just goes.
he's like the Energizer Bunny.
oh my goodness.
Wait,
Yeah. You can conclude that this is parallel, the parallelogram thing that we did. Okay.
wait, how do you know it was me? Could have been Will.
It could be wrong. That is true.
What if we have still have to take care of the other what?
How big is that parallelogram? The height is like
It's not
barely.
it's not big enough to fit square by themselves.
What's the distance between the opposite sides?
Not big enough.
Oh, wait, what? Actually, oh yeah, it is.
Wait, what if you literally just take like the midpoint between the midpoints?
uh,
Oh no, like the midpoint between the midpoint and the corner. That
okay,
isn't colored yet.
like here.
Yeah, like some point there.
Mhm.
Like if that's blue, is that big enough to get square already?
If that's blue,
It's pretty close to be able to fit the square already. I think.
Also, if it's pink, you have the same problem. Wait, wait.
It's not exactly the same, but I mean, it makes both of them.
How to create
hmm.
So, yeah.
right, so this is gonna be just
Alright, maybe Yasser, hold back on the spoilers for a bit.
Well,
You're too fast for them.
Okay, so you just wait and
Maybe
you
take
can
a
just
take a
carry on.
sneak peek at SA5 while you're waiting for them.
SA5.
Vanished to the
The
shadow.
top secret.
You didn't
top
manage
secret
to
location.
shut
It's too fast.
It's too speedy. Too speedy, yeah.
Yeah, I think the green point is interesting.
Yeah.
It's kind of weird. Like the distances get kind of. Okay, let's see how big this really is. The difference between. Is this big enough to fit a square already? What's the height of here?
Should work. But what about this case?
Wait, where's Will and George?
George.
Let me just ask: is everyone okay with what's going on so far?
Okay, I'm doing SA5 in a secret location on the whiteboard.
Decent.
Top secrets.
A non-spoiler location. Wait, if it's to the left of the spoiler sign, maybe do another arrow left. Yeah, so I guess I want to know the status of the green point now.
So if
This-
the green point is red, then
Oh, I think
then you win.
yeah, the green point has to be blue.
So it has to be
Yeah.
blue. So
Okay,
it's-
good.
yeah, blue.
Has to be blue, good. Because if it's red, then you get a square, right?
Yeah, you get a square like just straight down. And then you get a similar thing on the bottom.
Yeah,
The bottom.
same thing at the bottom.
Which one? Here?
Oh,
Yeah.
this is
That yeah, that's surely
Wait.
is good, right?
wait.
Surely this is cool. Let me pull this up.
But is this rectangle that we just drew big enough now?
It looks
It
fine.
is big enough. Hey,
Are you sure?
Still,
okay, we did it. I think. Yeah, I think we did it.
Okay, well if Alex is sure then
Wait,
Yeah,
wait,
we
but
did
the
it.
question. What if it
This
was?
is big
What if it doesn't even?
rectangle. Oh, it is. Because
What if it
the
doesn't
height-
have to be a
the height is
triangle?
like-
Wait,
Yeah.
maybe. What if it's 3, 4? Not necessarily a triangle.
Yeah. That height is more than one. Definitely.
Well, it's not a rectangle though. It doesn't matter.
Okay, it doesn't matter because the height is
Wait.
greater than one, and then the
Isn't it? Well, what?
Hmm?
It's not a rectangle, right?
wait. Oh wait, no. This is 2, 3.
It's still just a parallelogram.
Yeah, it's still a parallelogram, but it seems big enough.
very
it seems big enough. Seems big enough.
Wait.
How do
Are
we?
you on the whiteboard or some?
Seems
Are you
big
on the
enough.
whiteboard?
Whatever, I don't know.
what?
Oh my god.
What did Yasser say?
Wait, I did work on. I
did not realize.
people doing stuff on the whiteboard or on the actual whiteboard. Or,
This is
Oh,
5 and 4.
you mean like Alex stuff? You can't see what he's doing.
yeah.
Yeah, Alex.
Why is
Oh,
he
he's
on-
not really writing anything yet. If you, Alex, you want to write something, write on the whiteboard. He's saying.
Okay, we still need to figure this out properly.
Why is he on the real whiteboard?
This is code bashable.
IRL whiteboard.
This is code bashable.
Yeah, it's definitely fashionable. But can you just show it
Probably.
straight up?
Yeah, but then you need the trig.
Green tree?
Wait. Cause like, oh, this is kind of hard. This is
Oh,
big.
you can make it into a rectangle though.
Wait, can you?
But then the height's not 1. Oh wait, no, that's useless. Root 2. Yeah, root 2 is less than 1.
How to do this?
I mean, the height has to be bigger than 1, right?
What if we make? Okay, so let's say we make it a rectangle, right? So then this is 2 to 3. Wait.
I think you pick a point like here,
Yeah, you pick a point there,
and you
such
pick
that
a
this
point
is
here.
this is like 3/4. This length is 3/4. What's
and then you just use Pythagoras.
what's 1/2 squared? 1/4 plus.
I think they'll give you the
9/16.
finished product. At the moment, they're just
Wait,
rough
it's not
working.
big enough.
No, it's not big enough. They are. Yeah, I think
What
we're.
did I do? 1 on 4, 4 on 16, 13 on 16.
Bruh.
Why is it not big enough?
No, it's not big enough. Okay, we're gonna have to go this way then.
What? Which way?
We're like drawing rectangles.
Trying to make a rectangle.
Why rectangles? Don't you just need one by one?
Yeah, but it's like easy to calculate heights of rectangles.
Oh, okay.
Like the
Yeah,
parallelogram
but it's
is
not
like
big
really
enough,
big.
which is unfortunate. Which means that we will have to resort to desperate measures. How do you calculate the height of that thing?
Maybe
So is what you're doing right now?
No,
is,
no. I think you can just Wait, what do you want to do?
I guess there's a few things that's not on this diagram that could be. So, have you done some extra things onto here that you wanted to share with us?
Between this.
I mean, we just drew in like the lines with the other blue points.
So, for example, this point goes to what?
Like,
This one?
yeah,
There?
just drawing
That.
like a full hexagon.
3 on 2.
Like that,
three
yeah?
on two.
Lines are so bad.
Oh, okay. Maybe I'll draw it on a separate diagram. So, what they're doing right now is this.
Yeah, we can just do this, right? Try and make this 3 to 2. What? So then this is
That shape.
2/3. Then this height should be 1 plus.
Where is our square going? So is that distance big enough for a square?
Yeah.
Wait, no,
Those
I thought
lines
something
are
else.
parallel. Wait.
Yes.
Pretty sure I thought something else.
These lines are parallel, right?
So you're saying they can't both be blue, or
Well, they can be. Well, they can't be like size of the triangle.
So the question is, does a 1x1 square fit into there?
Yeah, that's what I'm trying to figure out.
wait, so where exactly is the
I
blue
am
point?
pretty confident that those
Wait, the blue point any point or
I can't
midpoint?
see.
They're midpoints.
Or it's the midpoint of the midpoint.
Yeah, it's midpoint between the midpoint.
The 3/4 point
Oh, God.
and the quarter point.
What
That's
is
a
that?
rectangle.
I think there has to be some like
Oh,
nice
wait a
one.
minute. We can do this.
Is the shape of a rectangle?
Like, what's the distance between the lines? Did you figure that out already?
No, we haven't.
No, we're struggling.
We're struggling with this trivial chord.
Well, we thought it was like a really strong enough balance to just make it easier, but then it wasn't good enough. Like we picked nicer points inside, but
So this is like the perpendicular distance between the two lines.
Yeah, I think we can just do this.
Oh, wait, you can do the area of the
Yeah.
parallelogram.
So,
oh
Wait,
no. Oh, the distance is just like
get this thing and then
Wait,
Wait, what? Area of
this
parallelogram.
thing and then you yeet it over. You yeet it over using the cosine. There you are. So what is this length? Well, this length is a half. This is at an angle of 3 seconds. This is 2 to 3, so therefore this has to be 3. Wait, hold on. This is the 3, so therefore this is 1/3. This is 1/3. 1/3 plus 1 equals 4/3. 4/3. And then this goes here. How does that work? Should work. 4 plus 3 halves over 30. Okay, dude, this is too much math for me. I don't. I just can't do arithmetic. I'm not capable of doing arithmetic.
Okay.
Divide by 3 seconds. 8 over 9 times this thing. Times square root of 13 over 9 equals.
I thought I was doing the same thing. 13 over 4. Root 13.
Wait, this is 13 over 4. Right, wait, what did you write here? Oh, it's 13 over 4.
Hypotenuse to on the side.
Yeah, it seems convincing enough.
Should I hand wave a calculation?
Seems convincing.
I can't do arithmetic. We can just square it, like, okay.
Yeah, I'm just doing it. It's not even that bad.
I'm sure you can 514 times 2 15 times 8 and 13 and
64 times 13.
5. Yeah, that's like almost 2 already. That's like so. 4 times root
6 times 3 is 18 plus 4. 22 times
30.
Yeah, also notice this is almost like the first example to the first part
Wait,
already.
what?
Yeah.
Did I mess up? Oh no.
4 times
That's 14 plus 4 over 15 over 4 root 13.
Okay, definitely.
Root 13.
It's less than 4.
Just square it.
Yeah.
Just square it. Square it? Yeah.
X squared equals 225 on 16 times 13. 16 times 13. What the hell 16 times 13?
Question 16
Equal.
times 13. It's 169 plus 3 times 13,
Bro, what are you.
which is 39.
Yeah, and that's less than 225.
Okay.
Okay, we did it. It's the height is more than
Oh, you got D equals this.
Hmm.
So what you got?
no, we got 225 on that.
Oh.
Yeah.
Yeah, and that's more than 1, so we're done.
Okay, we're done. How do you come up with this in 30 minutes? I don't understand.
I did feel like it was like some kind of, maybe like they didn't expect, it's like an adult thing that they didn't expect the kids to know. I certainly
The kids don't know anymore.
because it might take a while to discover the convexity idea. I don't know, but the convexity idea really does.
I mean, I already had convexity, but I just didn't think. Didn't have brain.
Okay.
Big ball of brain. With the big ball of brain.
The question is too difficult for kids.
kids are too small brain.
Oh no, I was just saying like it was probably I had an unfair advantage rather than like I was just particularly clever or anything like that.
The unfair advantage of being too clever.
No, of like knowing about convexity as like a knowledge point.
But like we knew about convexity and we couldn't.
No, but you
By the
figured
way.
out convexity. See, that's different.
No, but didn't we like do convexity in a few problems?
Okay, does that work then?
Yeah, I think it works. Oh,
Wait.
yeah, you have to prove the length.
Oh yeah, length is already done though.
Well.
The what?
Wait, no, it's not.
Oh, you have to prove this length is bigger than 1, yeah?
Yeah.
Well, not like a whole, because the heights they drop onto like a point.
Yeah,
That is
somewhere
close.
along it.
Like if you drop heights, from
Which
the-
one is closer?
Yeah,
Like drop heights.
Yeah, and you have to prove the.
That part's bigger than
This part's so bad.
Yeah, so as long as that point
It's
is
just a lot of symmetry. Yeah, I think it's the best way to calculate it.
Yeah, you just use similar right angle stuff.
yeah, as long as this point is to the right of this point. Because that'll be like the hypotenuse of a
And 1. Oh, yeah. Oh.
Oh yeah, I remember.
But I
like-
swear, for some reason, I don't remember doing a calculation for D.
Oh, did he show it some other way?
I don't think so. Let's see.
Did he just skip it, or did he just do some big brain method of
Spoil the 5 reveal?
5 is here.
Oh, we got literally the same.
Hmm.
I guess it's red instead of blue.
Okay, whose
And
winner
then-
was this?
That's a really big
How did
difference.
he show it?
Wait,
Oh,
who's
you
this
just
guy?
grabbed and did the calculation.
Wait, who's this?
That was my original rough working.
Yes.
I don't see much rough work. Wait.
Oh, you can just show like maybe you like show the distance from like the middle is half,
Oh yeah, I remember in like TT
Like he took the distance like from
From here to that
the
line.
first A level that I did,
Yeah, to
like
that
I just
line.
straight up wrote my
Oh, yeah.
like
I mean, that's a lot easier to bash at least. We wanted to bash.
Actually, maybe
Yeah.
I should show people the chord bash.
Oh, yes.
Wait, do you know the distance formula from a line and a point?
yeah.
It's like really annoying.
It's like
No,
this,
you
like
just
you have
plug it
ax
in and then
plus by plus c equals 0, yeah?
Oh, it has like
absolutely.
And then you have a point like
that.
xy, yeah?
yeah.
And the
You just
distance,
plug it in and then
the distance is, you
over,
plug in, wait, do you
over
do this
the
in school?
Pythagoras
Yeah,
of
we
A and
did.
B.
I never used it after like
Something.
year 8.
Yeah, I actually used it in extension 2 exam in high school. It's kind of crazy, it's just kind of like a random question.
Oh, a random.
Yeah, and random questions were good at the time because no one else could do it.
For some
The
reason, like
ax, so
we
you
have that
sub in
coordinate
x, you
field.
sub in the point, right? Yeah.
Uh-huh.
Oh, I remember the question now. So you sub in the point, yeah?
Uh-huh.
Put in the absolute values and you divide it by the square root of a squared plus b squared.
Oh, yeah, I remember.
So that's the distance between,
A and B.
yeah. Yeah, I remember now. So there's actually a little bit more insight into the formula. Was like, oh, what was it? It was something about how to resolve the absolute values. Like,
Square by size.
oh, it was like something about the point being on the left or right of the line,
Oh.
and the absolute value is like just positive on that.
Ah, so it's like
I don't
the
know.
signed distance.
Yeah,
Signed.
yeah, I remember that. That's where I lost the mark in the question because I couldn't figure out how to get rid of the absolute values properly.
Don't
But-
you just delete them?
I mean, you don't have actual numbers.
Oh,
Yeah.
Yeah. You just have to.
Yeah,
delete
so there's a little bit of extra.
I'm
Oh,
sure-
it's pretty funny. And Singh is like doing this kind of stuff like right now.
Oh.
He's doing the entrance exam for Beijing University,
Beijing.
and it's funny. It's like a lot of like this kind of thing, and I was asking you like, and it's assumed you know about conics.
Oh.
So it's like, what is the shortest distance between this line and this ellipse?
Oh, no. Oh,
Yeah.
no. Can I use like calculus for that?
Yeah.
Oh.
But like, then there's some questions which are like designed to troll calculus
You're
people.
like parameters.
So it's like there's like basically they have like a line, right, and they have a point, and it's like find the product of the like they did this funny algebraic expression which is really just the power of the point, and it's like and they express it in terms of like the minimum distance to the circle and the maximum distance, like it's all like x minus 2
oh.
square root, and it's like what is the product of the minimum times the product of the maximum.
I see.
Wait, that's just power.
Yeah, and then
And
like,
everyone's
it's just
actually
doing
on
like
the
derivatives and yeah.
They're trolling. They're trolling.
Okay, wait, are we happy with that? Is there
Yeah.
anything else we need to do for that? Because I was kind of worried.
We
It took
need to, like,
it was
learn-
quite quick. Yes.
Yeah, well, it was not SA7.
It's kind of yeah, like our kind of the mysterious enigma of question 7. Like it's gone down. Yeah.
Okay.
It's like, but then when the question is stated, like, how can you make this question hard, really, right? It's like a 2x2 grid with triangles.
Yeah.
It's like literally you can understand this question in primary school.
Yeah.
Okay, are there any questions?
Seems like
Okay, my secret
Oh.
Wi-Fi corner.
Actually, I was kind of thinking. Wait, if I look at the test,
SA5.
if we look at the test,
What do we solve 5, 6, and 7 right now and get full marks in SA7?
oh,
OP.
you just
dude, Lucas is like asleep.
man's just sleeping. Sure.
Maybe that's the true way to learn. Because you know how you have to consolidate your knowledge when you sleep. He's just directly asleep. Just lets it
right
process.
after you learn
He
something.
doesn't waste the time in
it's really
between.
wild.
Yeah, like
It's like people put it on the
he learns the
cassettes.
thing and then he just goes to sleep immediately, and then his brain does the clearing up for him.
Yeah.
Okay, and how to do question 6? I
Hold on.
haven't even read. This is
Actually,
JA7. Yeah,
I guess
JA7.
a point of strategy. I mean, like if this question is like sometimes like there's two parts and it's 6 and 6. It makes it much better to not like attempt question like 1 and 2, right? Because you're getting the 6 points anyway. You know.
True.
5, 7, 7, 7.
Yeah. It's weird. There wasn't many overlaps. It was just a question of 6.
Yeah.
How do you do question 6? I still have not solved. Like,
Wait. Should he be awake for the planning part?
probably should. Maybe.